The inspector's statement regarding a ground rod being the primary grounding electrode conductor, or GEC, requirement per the National Electrical Code, or NEC, is inaccurate. NEC Section 250.52 A1 specifies that the GEC must connect to the service equipment enclosure and the grounding electrode system at the service entrance. A ground rod is merely a component within that system, not the primary requirement. Furthermore, while the NEC doesn't dictate the GEC material, local amendments in certain jurisdictions may mandate solid copper. Regarding the panel's proximity to the laundry sink, the NEC doesn't explicitly prohibit panel installations within 6 feet of such a fixture. However, it's plausible that a local city amendment introduces this restriction. In such cases, firstly, request a written code violation from the inspector, demanding a specific NEC section citation justifying the request. Secondly, thoroughly review the city's adopted NEC version, scrutinizing local amendments for relevant stipulations. Thirdly, if the inspector and the supervisor fail to provide a valid code reference, escalate the issue to the building department head, clearly articulating the situation. Fourthly, as a last resort, consider seeking legal recourse to ensure NEC compliance. It's crucial to uphold accurate NEC applications and resist arbitrary or erroneous interpretations enforced by inspectors. Grounding electrode systems are covered in Article 250 of the National Electrical Code. The grounding electrode system is a critical safety component of an electrical system, providing a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices like circuit breakers or fuses. This helps to minimize the risk of electrical shock and fire. According to NEC 250.50, all grounding electrodes described in 250.52 A1 through A7 that are present at each building or structure served must be bonded together to form the grounding electrode system. This creates a single, interconnected grounding system. Permissible grounding electrodes are detailed in NEC 250.52 A1 through A7. A1. Metal underground water pipe requires certain conditions to be met. This electrode must be in direct contact with the earth for at least 10 feet, including any metal supporting structures. It also necessitates supplemental electrodes as described in 250.53. A2. Metal in ground support structures is another option. A3. Concrete encased electrode, often referred to as a U for ground, consists of at least 20 feet of bare copper conductor not smaller than 4 AWG encased within at least 2 inches of concrete. It needs to be located within the bottom of a concrete foundation or footing that is in direct contact with the earth. A4. Ground ring encircles the building or structure. It must be buried at a depth of at least 30 inches and consist of bare copper conductor not smaller than 2 AWG. A5. Rod and pipe electrodes must meet specific requirements. Electrodes of rod or pipe that do not have a resistance to ground of 25 ohms or less must be supplemented by an additional electrode of a type specified in 250.52 A2 through A7. Where multiple rod or pipe electrodes are installed to meet the requirement of this section, they must be spaced not less than 6 feet apart. A6. Other listed electrodes are permitted, such as ground plates. A7. Other local metal underground systems or structures can also be used. The grounding electrode conductor, or GEC, connects the grounding electrode or grounding electrode system to the service equipment or separately derived system. The size of the GEC is determined by NEC 250.66 based on the size of the service entrance conductors. For example, for service entrance conductors of 2/0 American wire gauge, or AUG, copper or 4/0 AWG aluminum, the GEC must be at least 4 AWG copper or 2 AWG aluminum. The GEC must be continuous or spliced only by reversible compression type connectors listed for the purpose per NEC 250.64. C. Protection of grounding electrode conductors is outlined in NEC 250.64. B. A GEC that is subject to physical damage must be protected by rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, electrical metallic tubing, or cable armor. The NEC requires all metal enclosures for GEC to be electrically continuous and securely fastened to the grounding electrode and the enclosure. Bonding jumpers play a role as well. Bonding jumpers are used to connect different parts of the electrical system to ensure electrical continuity and a low impedance path for fault current. Main bonding jumper is located at the service equipment and connects the equipment grounding conductor, or EC, to the grounded conductor, typically the neutral, per NEC 250.28. Equipment bonding jumpers connect non-current carrying metal parts of equipment to the EGC, ensuring that these parts are at the same electrical potential as the EGC. Supply-side bonding jumpers are used to bond metal enclosures and raceways containing service entrance conductors per NEC 250.92. Grounding systems for separately derived systems, such as generators or transformers, must comply with NEC 250.30. The GEC for a separately derived system is sized based on the derived phase conductors, in accordance with NEC 250.66. A bonding jumper is used to connect the equipment grounding conductors of the separately derived system to the grounded conductor, typically at the source of the separately derived system. Grounding electrode system resistance is detailed in NEC 250.53. A2. If a single rod, pipe, or plate electrode does not have a resistance to ground of 25 ohms or less, it must be supplemented by an additional electrode of a type specified in 250.52. A2 through A7. The 25 ohms resistance requirement is intended to ensure that the grounding electrode provides a sufficiently low impedance path for fault current. Ground testing is a vital step. Ground testing is performed using a ground resistance tester, also known as a ground measure. This instrument measures the resistance of the grounding electrode to remote earth. The test involves driving auxiliary electrodes into the earth and measuring the voltage drop and current flow to calculate the resistance. Common grounding mistakes to avoid include: firstly, improper GEC sizing. Ensure that the GEC is sized correctly based on the size of the service entrance conductors, as specified in NEC 250.66. Secondly, inadequate bonding. Verify that all metal enclosures, raceways, and equipment are properly bonded to the grounding system. Thirdly, use of improper connectors. Use only listed connectors suitable for grounding and bonding purposes. Fourthly, failure to supplement rod electrodes. If a single rod electrode does not meet the 25 ohms resistance requirement, install a supplemental electrode. Fifthly, neglecting local amendments. Be aware of any local amendments to the NEC that may affect grounding requirements. Proper grounding is essential for electrical safety, and it is important to follow the requirements of the NEC and any local amendments. The grounding electrode system provides a low impedance path for fault current, helping to protect people and equipment from electrical shock and fire hazards. Regular inspection and testing of the grounding system are essential to ensure its effectiveness. Regarding the specific question about the laundry sink and the electrical panel location, it's important to clarify the relevant sections of the National Electrical Code and address potential misinterpretations. The NEC doesn't explicitly state a prohibition against installing an electrical panel within 6 feet of a laundry sink. However, the interpretation might stem from general safety principles or local amendments. Consider the following aspects. Firstly, NEC 110.26 deals with workspace about electrical equipment. This section mandates sufficient access and working space around electrical equipment to allow safe operation and maintenance. While it doesn't specify a distance from a water source like a laundry sink, the general requirement for a safe working environment might be a point of contention. Secondly, NEC 210.8 discusses ground fault circuit interrupter, or GFCI, protection. GFCI protection is required for receptacles in various locations, including bathrooms, kitchens, and areas where electrical equipment is likely to come into contact with water. If the laundry sink area is considered a location where such contact is probable, GFCI protection might be necessary for any receptacles in that vicinity. However, this doesn't directly prohibit the panel's location. Thirdly, local amendment should be checked. It is possible that the local jurisdiction has adopted amendments to the NEC that include specific restrictions on the placement of electrical panels near water sources. These amendments can vary widely, so it's crucial to consult the local electrical code. Fourthly, inspectors' interpretation should be considered. The inspector's interpretation might be based on a general concern for safety and the potential for water to come into contact with electrical equipment. While not explicitly stated in the NEC, this concern could lead to a request to relocate the panel. In order to address this issue, several steps can be taken. Firstly, request a written clarification. Ask the inspector to provide a written explanation of the code section that is being violated. This will help to understand the basis for the requirement and determine if it is a valid interpretation of the NEC or a local amendment. Secondly, consult local authorities. Contact the local building department or electrical inspection authority to clarify whether there are any local amendments that apply to the placement of electrical panels near water sources. Thirdly, review NEC 110.26. Ensure that the installation complies with the requirements for working space around electrical equipment. Even if there is no specific distance requirement, the installation must provide sufficient space for safe operation and maintenance. Fourthly, provide GFCI protection. If there is any concern about the potential for water to come into contact with the electrical equipment, install GFCI protection for any receptacles in the vicinity of the laundry sink. Fifthly, seek a second opinion. If the inspector's interpretation seems unreasonable or unsupported by the code, consider seeking a second opinion from another qualified electrical inspector or engineer. By taking these steps, it's possible to address the inspector's concerns and ensure that the installation complies with the applicable codes and standards. It is important to maintain a professional and respectful approach throughout the process, and to work collaboratively with the inspector to find a solution that meets the requirements of the code and provides for a safe electrical installation. The NEC is a comprehensive document, and its proper application requires careful consideration of all relevant sections and any local amendments. When in doubt, it is always best to consult with a qualified electrical professional. Article 408 in the NEC covers switchboards, switchgear, and panel boards. These are essential components of electrical distribution systems in buildings and other structures. Panel boards are designed to protect circuits from overcurrents, and they house circuit breakers or fuses that disconnect power to a circuit in the event of an overload or short circuit. NEC 408.3 addresses support and arrangement of busbars and conductors. Busbars and conductors must be securely supported and arranged to prevent physical damage and electrical stress. The arrangement must allow for easy access and maintenance. NEC 408.5 addresses the spacing between live parts. Sufficient spacing must be maintained between live parts of different potential and between live parts and grounded metal parts to prevent arcing and flashover. NEC 408.6 addresses the application restrictions. Panel boards must be used within their listed voltage and current ratings. They must not be used in locations where they are exposed to physical damage or corrosive environments unless they are specifically designed for such applications. NEC 408.36 addresses overcurrent protection. Panel boards must be protected by overcurrent devices such as circuit breakers or fuses that are sized to protect the panel board and the connected circuits. The overcurrent devices must be readily accessible and must be marked to indicate their current rating. NEC 408.38 addresses the number of overcurrent devices. The number of overcurrent devices in a panel board is limited by the panel board's design and listing. The panel board must not be overloaded by installing too many overcurrent devices. NEC 408.41 addresses enclosure. Panel boards must be enclosed in metal cabinets or enclosures that provide protection from physical damage and prevent access to live parts. The enclosure must be securely mounted and must be grounded in accordance with NEC 250. NEC 408.55 addresses location. Panel boards must be installed in readily accessible locations. They must not be installed in bathrooms, toilet rooms, or similar damp or wet locations unless they are specifically designed for such applications. Panel boards must not be located in closed closets or storage areas where they could be obstructed or damaged. NEC 408.56 addresses working space. Sufficient working space must be provided around panel boards to allow for safe operation and maintenance. The working space must comply with the requirements of NEC 110.26. NEC 408.70 addresses grounding. Panel boards must be grounded in accordance with NEC 250 to provide a low impedance path for fault current. The grounding conductor must be sized in accordance with NEC 250.66. NEC 408.71 addresses bonding. All metal parts of the panel board, including the enclosure, must be bonded together to ensure electrical continuity. The bonding conductor must be sized in accordance with NEC 250.102. NEC 408.72 addresses neutral connections. The neutral conductor must be properly connected to the neutral bus in the panel board. The neutral bus must be insulated from the enclosure except for the point where it is bonded to the grounding electrode conductor. NEC 408.73 addresses phase arrangement. The phase conductors must be arranged in a consistent manner throughout the panel board to prevent confusion and errors. The phase arrangement must comply with the requirements of NEC 215.8 and 230.56. NEC 408.74 addresses identification. All circuits in the panel board must be clearly identified to indicate their purpose and the area they serve. The circuit identification must be legible and must be maintained throughout the life of the installation. NEC 408.75 addresses circuit directory. A circuit directory must be provided at each panel board to indicate the location of each circuit and the area it serves. The circuit directory must be legible and must be updated whenever circuits are added or changed. NEC 408.76 addresses spare overcurrent devices. Spare overcurrent devices must be provided in the panel board to allow for future circuit additions. The spare overcurrent devices must be of the same type and rating as the existing overcurrent devices.